All right, so we have here our agenda for the day, which is going to be taking a look at some examples of what the Ed puzzle on Tuesday was all about, as well as our assignment in ALEKS on Tuesday. So the McGraw-Hill textbook has quite a few examples that I hope do a pretty good job of helping us clear up the ideas, which were what in the world is the definition of function in the world of math, and then how do I look at the different representations of a relation and know that I'm looking at a function? Hey, Jalea, good to see you.
Why is she here?
To make sure that she...
Is there a problem with me being here, Malcolm?
Okay, already. So the different representations of the relation, remember, we've looked at them in the form of a set of ordered pairs. So in set notation, we've looked at them in the form of a mapping, in the form of tables. We've looked at them in the as a graph on the coordinate plane. So we're going to make sure we understand how to look at each one of those and know whether or not it is a function. If I go backwards for just a second, I did get, this is really what we started on Tuesday, but I didn't have this learning intention in our slide deck on Tuesday. So we are trying to make sure we can identify a function when given a relation. And so the success criteria here are, I can explain the mathematical definition of a function. I can identify a function. The rest of these are all, I can identify a function when given a relation. This one says in set notation. This one says when I'm given a relation as a mapping, when I'm given a relation graphed on the coordinate plane. So that's really all that we're focused on going over this. It's what the puzzle from Tuesday was about. It's what this is about. It's what this assignment from Tuesday was about. And I thought we could leave questions about it until after we run through the textbook stuff. And then maybe we'll understand it even more. And then this textbook assignment today is similar to, it actually incorporates evaluating functions that we've done in the past, because I don't want us to forget how to do that, as well as identifying functions. Any questions at the moment?
No.
All right, well, let's see if we can run through this textbook stuff. I think maybe we're gonna do some switch up here real quick. Thanks for your quick patience here. We got this, we got this, and so we're going to the textbook. You guys know, or hopefully remember anyway, that we get there by going through Clever. So little blue background with a white C on it, either up there on the bar or down here, or you can just type in clever.com. And it's this red icon. It says McGraw-Hill. I think underneath it says SSO when you're in Clever. And then we go into our Algebra 1 textbook. We are on Module 3 of Algebra 1, and we are on Lesson 2. So going down here on Module 3, going to Lesson 2. So I'm not trying to say you guys have to come with me, but this is a good resource about functions for you to at least be aware of how to get to it. I'm going to launch this presentation, and we're not doing everything. Let me try opening this tray here, and we're going to start with today's vocabulary. So this definition of function right here was in the Ed puzzle video, and I did a quick synopsis of it on Tuesday. But a function is simply a relation in which each element of the domain is paired with exactly one element of the range. And just reminders about domain and range. Domain is the input. Domain is your x coordinate when you're looking at an ordered pair, so it's your x's. And one other way to think about it, if it's your input, when we're talking about real world situations, that typically means it's what you're starting with. To be able to input it into something, you have to already have it. You input it into a rule, and then that rule gives you some sort of output. So what makes it a function is if every time you put the same thing in, the output is exactly one thing and always the same one thing. So that's what would make it a function. Our range then is the output. It's what you get back from whatever you put in, and it's the letter Y in an ordered pair, X and Y. All right, so that's definition. Function notation is what we did first. The textbook actually goes there second, but we did it first. So the second half of this lesson that we're not going to cover right now does have examples about function notation. But just a reminder that when we see things like f of x and g of x and h of x, that's function notation, which is very interchangeable with y. So if you feel all confused because you're looking at f of x equals 2x plus 1, just rewrite it, get rid of the f of x and write it as y equals 2x plus 1 if that makes your brain feel more comfy. Okay, there are a couple of conveniences to function notation that we've talked about in the past. But let's look at the first thing with regard to how do we know that something's a function. This vertical line test is all about when I'm looking at a graph on the coordinate plane, I can use this test as a way to determine if something's a function. And I've highlighted using the textbook's highlighter here, the really important part. You know something's a function if a vertical line passes through only one point. The way this states it is if a vertical line passes through more than one point in a graph, the relation's not a function. So in this graph right here, this green line is our vertical line representation. And the nice thing is I can move it wherever I want to. If I was doing this with you in the classroom and I was doing it on a dry erase board or chalkboard, I'd be drawing a bunch of different vertical lines. But that's just something nice about technology. I can just move one vertical line around to see, does this vertical line ever intersect this graph in more than one place? And the answer is no. Everywhere I go, you see that black dot right there is telling me that's the only place it intersects when I'm looking at that particular location. All right, so in exercise 1 here, it's asking us which of the relations are functions. And right now I'm looking at relation 1. And this relation, because every vertical line only hits the graph one time, is definitely a function. We're going to explain why that's the case, why it's so important about vertical lines hitting it only once in just a minute. But let's just look at another one. The third one we look at here, I'll talk a little more about the reason why. So this is relation 2. And when I start moving this around to look at vertical lines in different places, I see everywhere I go, I've only got one black dot because my vertical lines are each intersecting the graph only one time. That's how I know it's a function for sure. So both relation 1 and relation 2 have been functions so far. Here comes relation 3. And check that out. Already, I see this vertical line is intersecting this graph in more than one place. And there's lots. Hey, Dion. Lots of vertical lines that do that. So let's try and be a little more specific here about what's going on with a vertical line. So we know that this guy right here is the x-axis. All right. And where I've placed the vertical line right now, this would have been the origin. Where the vertical line is -1, it's -2, the x value -2. And what's so helpful about the vertical line is it's marking everywhere that I can see the graph right now that has an x value of -2. Everywhere that green is, you're talking about an x value of -2. Since our functions are defined as every x value, such as this x value of -2, has to have exactly one y value. That's why a vertical line has to only intersect my graph one time, because that's the one value it's assigned. If I actually take a second here and write down the ordered pairs for this, we already said this is an x value of -2. Its y value looks like it's about halfway between -1 and -2. So I'm going to write the coordinates, the ordered pair for this point is -2 for an x value and -1.5 for a y value. Okay, so that's -2 comma -1.5, and up here I'm still at -2, but my y value this time appears to be about 7.5. So -2, 7.5. And so that's just showing us in another clear manner that we have an x value of -2, that this relation is assigning two different values in the range, the output, the y values. Okay, that's why it's not a function. That's why our vertical line has to intersect the relation in only one point, so that it's proving to us that that x value has only one y value assigned to it. All right, let's clear that out of there. Did anybody have a question before I clear this out?
What'd you say?
Did anybody have a question about relation 3 and the vertical line test before I clear out my writing?
Yes, the quiz from yesterday. So why I did it, and 4 of the answers I have gotten were all partially correct, and I got so upset. And then I got one answer wrong, and then one answer right. I said, "What is this test?" I said, "What is this quiz?"
Yeah, it was not about what we're talking about right now, but I will be glad to take a look at that with you.
Yeah.
I mean, yeah, it was a little bit more than what you were talking about, but I understand it a little bit. But when I said when I found out that it was partially correct, I said, "What in the world is this?"
And Malcolm, I thought you were talking about the quiz that we did on Monday. You're talking about our Alex assignment from Tuesday.
Yep.
Okay, I'm with you, and you're right. That is my biggest beef with Alex is they give
That's
you
why.
one page with 5 different things on it, and they won't tell you which part of it's wrong.
That's why I have a C in your class, because of Alex. So many Alex assignments got me. Like I had a 68, then maybe a 50, then maybe a 75. That's why I got a C in your class.
But all the assignments other than the quizzes, you can do as many times as you need to get to your 100. And there are me and Mr. Blake and all of City Year, et cetera, to help you out. So you just gotta, I'm glad you let us know. You just gotta let us know like that, and then we can make sure we take some time to look at it.
The reason why I didn't do it again, because I gave up.
That's fine. I understand. And you had only seen the video. So it may be that when we're done here, that'll be way easier for you to go back and be like, oh, now I see what the heck was going on.
I said in my mind, after I did the test, I said, from now on, I do not care.
You do too. All right, we're going to keep rolling. Wait a minute. Relation 3 was not a function. Therefore, I'm not checking it off because this is all the ones that are functions. Here's relation 4. No matter where I put my vertical line, it's showing me that every x value is only assigned a single y value. So that makes this a function. Relation 4 is a function. Okay, relation 5 very clearly is showing me that lots of x values are assigned more than one y value. If I look at this x value of +1, it's assigned a y value of 3 right there. But the same x value of 1 is also assigned a y value of 5. That's why it cannot be a function. So relation 5 is not a function. Here's something I've been saying to all my classes, and I'll just say to you, another way to look at these graphs, another thing that the vertical line test is really saying to us is there any part of the graph that is directly above or below another part of the graph? Which the answer here is really obviously yes. This whole thing up here is directly above this whole part down here. And when you see that kind of situation, it can't be a function then. All right, so now we got this blue horizontal line, and there is no way that a vertical line would ever pass through a horizontal line more than once. So that makes it a function. Then the next one, this is actually an absolute value graph, as you see right there. It's representing the absolute value of 2x minus 4, and there is not any part of it that is directly above or below another part. Every vertical line I check is going to be passing through it only once. So it's a function. And relation 8. This one's a little bit tricky. It would be easier if we were doing this in Desmos and we could zoom in, because then we'd be able to see that this is actually slanted from left to right all the way up. The way it is right now, that almost looks like it's vertical, but we can use this vertical line to also see that as I go, nowhere do 2 black dots show up. It just goes up very quickly and keeps going to the right. So there is nothing, no situation where a vertical line will pass through that graph twice or 3 times or more. So it is a function. Any questions on all these graphs we just looked at? All right, if not, we can go to the next resource in our textbook, which is really just, again, defining functions like we did when we looked at the vocabulary. So a function is a relationship between input and output. In a function, there's exactly one output for each input. And here it says that again in words in a formal definition. Exactly, every domain element has exactly one element in the range. Same thing we just said here, exactly one output for each input. In the form of a mapping, what we're really focused on is the domain. Does every element in the domain, that would be a -6, a -3, a 1, and a 4 in this example, does each of those only get paired with one element in the range? And the answer is yes. -6 goes to 8, -3 goes to 5, 1 goes to a 0, and 4 goes to a -2. So that's definitely a function. We've already done a bunch of graphs, so hopefully we're catching on to this would be a function. It would definitely pass the vertical line test. All right, so now let's identify some functions again. This is all about mappings, and a function is all about what's going on with each member of the domain. Do they get paired with exactly one member in the range? -4 is paired with one member of the range. -2 is paired with one member of the range. +2 paired with one member of the range. And 5 paired with one member of the range. It's that simple. Just don't let your mind get distracted by other things. Every one of the domain has exactly one partner in the range. Okay. Don't let the fact that this guy happens to be a partner of 2 different people over here, that doesn't matter. Everybody in the domain has only one number assigned to it in the range. That's what matters. This is definitely a function. The next one, this is a table. And so again, it's all about, does every element of the domain only have one element of the range assigned to it? So what I really have to do is look at the domain. There's a 2, there's a 6, there's an 8. So far, this is absolutely a function, right up until I see that the 2 gets repeated. That's not even a problem until I see it's assigned a different range value. 2, 3 here, with a 2 and a +3 right here, it would have still been a function. It's the fact that 2 has more than one element in the range, so it's not a function. Similar here, I'm looking at every domain value. In a set of ordered pairs, that's every x value, so the first number in each ordered pair. The 2 is in the domain, the 4 is in the domain, and the 8 is in the domain. For these first 3, we definitely are dealing with a function, but then we get to a repeated value of 4 in the domain, and the second time 4 shows up, it's assigned to a different value in the range, so this is not a function. Any questions? Okay, here's some more examples. I'll try and do them pretty quick, but you guys just ask all the questions you need to. This example A right here is the first time that we see a mapping where it's not a function. 2 has exactly one element in the range, but 3 has 2 different range values. It cannot be a function then. Everything else about that mapping would have made it a function. It's only the problem with 3. When I look at B, every element here in the range only gets assigned to one element. Every element here in the domain only gets assigned to one element in the range, so it is a function. Looking at C, I have a 3 in the domain, a 5 in the domain, a 1 in the domain. Now I see 1 in the domain a second time, and it's assigned a different range value, not a function. And then this table, looking at all of these domain values, -4, -3, 0, 2, 5, they're all different domain values. So every one of them only is assigned one value in the range, and that makes it a function. All right. So when you're trying to find out if something's a function, say to yourself, domain, domain, domain. Does everything in the domain only have one element in the range? We have two examples here that are real world type examples. I'm not going to go through every part that the textbook has set up for us, even though they are pretty nice, but I just want to make sure we can at least think about, okay, here's a real world example. What do we mean by domain? What do we mean by range? So this is a long jump situation. 5 schools are competing in the long jump portion of a track meet. The distances of the players with the best jump on each team are as follows. So team 1, their best distance for a long jump was 20.6 feet. Team 2, the best distance for a long jump was 21.5 feet. And we just keep going with the team 3, 4, and 5, same ideas. So when we're trying to think about domain and range here, domain is inputs. Domain is what we start with. And so we started with each of those teams. We started with team 1, and then team 1 went out there and did long jumps, and the result for the best long jump was 20.6 feet. So that's our output. What team it is our input. Their best long jump is the output. Okay. So if I want to think about whether or not this is a function, then all I have to ask myself is, does every team, which is our domain values, team 1, team 2, team 3, team 4, and team 5, do every one of them only have one best long jump distance assigned to them? And the answer is yes. If it's the best, there's only one of those. And so this would be a function because each domain element has exactly one value in the range. Another kind of real world example, we've got Madison, who took 5 quizzes this semester. Her scores on the quizzes are as follows. Quiz 1, she got an 86. Quiz 2, a 92. Quiz 3, a 78, and so on. First, it says determine the domain and range. Domain is my input. What did I start with, a score of 86 or quiz 1? I started with a blank quiz 1, so that's my input. Madison took the quiz, and the output of her quiz was a score of 86. So the domain is going to be the name of each quiz, quiz 1, 2, 3, 4, and 5. So they gave us this drag and drop stuff. All the domain numbers would be the numbers that relate to the name of the quiz. And then there are 5 quizzes, but now I've only got 1, 2, 3, 4 numbers left. That's because on quiz 1, Madison got an 86, and then on quiz 4, Madison got an 86 again. But all of these quiz scores are the output values, so we'll drag them into the range. And then if we're asking ourselves, is it a function? Well, since I started with the quizzes, that's my domain, and I ended up with quiz scores, is there any quiz that has more than one score on it? Nope. Each quiz has exactly one score, so it is a function. All right, I'm not really going to look at this example 3. This is example 3 and an extra practice example 3, except to say that they're taking equations and saying, how do we know if it's a function? And the answer would be, we're not really focused on this, but I at least want to mention this to you. The answer would be, take your equation, put it in Desmos. Desmos will make a graph of it like this, and then you can figure it out pretty quickly using the vertical line test. So this, if this is its graph, is definitely a function. And then the next one, same idea. We've got an equation. If I am just given this equation and I want to know if it's a function, put it in Desmos, let Desmos graph it, and then check it out with the vertical line test. Again, this one is a yes, because the vertical line test tells us every element of the domain has exactly one element in the range assigned to it. Okay, so this is a 4-question check that I want to walk through with you. Not asking you to do it necessarily, but you're welcome to if you would like. The rest of this is about evaluating functions, what we did before we learned this definition. So I'm not going to do more beyond this nice little check right here. Question 1 says, which of the relations are functions? I'm hoping that we're getting familiar enough now to know, well, we just need to look at each domain value, and every one of them is assigned to one range value. I don't even care what range value they're assigned to, but I can see because of the arrow that each one has just one friend over there. This is definitely a function. In the table, domain value 0, 2, 4, 0 just repeated itself. 0 was assigned the range value of 8, and now it's got a different range value, not a function. This set notation, where it's a set of ordered pairs, I have a -4 in my range, a -2, a 1, -2 just showed up again. Here my -2 was assigned a range value of 1. Here my -2 gets a -7, not a function. I've got a domain value that's got more than one range value. So the answer here is only relation 1, the mapping, was actually a function. Please don't hesitate to unmute yourself or throw something if you've got any questions at all. Next question. Another kind of real world situation. Bailey recorded the heights of 5 of her friends. The heights in inches are as follows. And then we see her friend's name, Hunter, and a height of 62 inches, and her friend Ling, height of 66. Again, we're thinking, okay, if I got to think about domain and range, domain is inputs. What was my starting point? My starting point was that I had friends, or Bailey's starting point was that she had friends. So her friends' names are going to be the input, the domain. And the output was she went along and measured each of them and got their heights. So domain, each friend's name, range is going to be each of those heights. And so C right here is telling us the correct domain, all of her friends' names, and the correct range, all of their heights. All right, on question 3, we're back to what we started with, the vertical line test, trying to figure out, is this a function? So if I started drawing vertical lines, the first problem I see is when I draw a vertical line down the y-axis, it's going to hit 2 points, and that makes this not a function. I want to pause here again and try and share something that I know is in Alex, but isn't in any of these examples. So we can ignore these other points for a minute, and I just want to draw an example of one other type of problem that I know Alex provides that the textbook doesn't talk about. So you see this is a shaded in circle versus this is a wide open circle. I didn't do the best job on my wide open circle there. If it looks like this, where the open circle is on an x value of -1, but then I have a closed circle on -1, this would be a function because the open circle is not a point on the graph. It's a boundary showing that this line segment goes all the way up to -2, but stops right before it gets to, I'm sorry, -1, right before it stops right before it gets to -1. So even though I could draw this vertical line, if I could draw it a little better, it's not wonderful, but the idea is even though it goes through an open circle, that's not a point on the graph. This is a point on the graph. Therefore, that vertical line only hits it once. This would be a function. Of course, I'm sure you can already clearly see that if it was something like this, now it's definitely not a function because a vertical line would go through, hit this point and this point, or go through and hit 2 points here. So just look at that closely. If they truly overlap one another, above and below, then it's not going to be a function. But if you got an open circle and then a closed circle directly below it and everything else is over to the right or something, then you would be looking at a function because vertical lines would only hit things once. All right. Any questions, guys?
Wait, so although there's two dots on the y-axis, it would still be a function? Or did you say it wasn't a function? Because I misheard you.
I said this one is not. This one's definitely not a function. But then when I was doing the red drawings, I was only talking about the red stuff that I was drawing, totally unrelated to this question.
Okay.
Thank you for asking for that clarification, Julia. So what we're looking at right here is not a function. I just wanted to clarify about those open circles that you come across in ALEKS. An open circle is not a point on the graph. This next one is an absolute value graph again, and there is nowhere that I would be drawing a vertical line that could hit it more than one time, so this is definitely a function. Another one that I could draw as many vertical lines as I want, and every one of them would hit it only one time, so that makes it a function. And here's another one that we know there's a bunch of vertical lines I could draw, and it would hit the graph more than once, so it's not a function. Oops. All right. Any questions?
No, sir.
We've run ourselves almost to the very end of class here. Question 4 is just several statements that hopefully are beginning to make some sense. Like we can answer these now just because we've blabbered so much. It says the question here is, does this describe a function? And so the relation passes the vertical line test. That would mean every vertical line you can come up with only hits the graph one time. So if it passes the vertical line test, then yes, it's a function. An element of the domain is paired with only two elements of the range. No way. Every element of the domain can only be paired with one element in the range. So that second statement would not be a function. A vertical line passes through more than one point on the graph. Can't be a function. The domain represents each student in class, while the range represents the age of each student. Well, every element in the domain is a student, and every element in the range is a student's age, and no student could have more than one age at any given point in time. So yes, this is a function. Every element in the domain has one element in the range. The domain represents the number of a day in May, and the range is the high temperature of that day. Well, it's kind of like the best long jump. The highest temperature, there's only going to be one high temperature any day. And therefore, this would be a function. No matter what day you're talking about, it will be assigned exactly one high temperature. And this one would be, again, stick it in Desmos and see what this graph would represent is U that's either right side up or upside down, known as a parabola. And so, yes, it would be a function, but that would be what I expect you to know the least, unless we actually put it in Desmos to see what it looks like. All right, that is where I am officially stopping. I had hoped to give you some time to work on this other assignment of 5 problems, but did anybody have questions about yesterday's assignment? Just any questions in general that you'd like us to look at?